Impregilo SPA, listed on the Milan Stock Exchange, is Italy's leading engineering and general contracting company in both the construction and environment sectors, and it's among the main groups on an international level. Impregilo SPA as a company has been active on 5 continents since 1959, while the original shareholders were present on the worldwide market since the beginning of the past century. From the early 1900s and after the First World War, Girola and Lodigiani, and later Impresi, took part in the construction of major civil engineering works and infrastructure projects, both in Italy and abroad. Subsequently to the incorporation of Cogefar and Impresi, Girola, Lodigiani, the international market was jointly pursued by said companies on a highly competitive basis, participating in the construction of huge projects the world over. The head offices are in Milan, but Impregilo is operative in many parts of the world. Impregilo employs over 20,000 people throughout the world, of which over 1,000 are engineers. December 31, 2007, the group had a total revenue of €2,530 million, that's construction works only, and a construction backlog of €16,944 million. For the execution of the 6th Crossing Suspended Arch Bridge, Impregilo will work very closely with the nominated subcontractors, Cimolai SPA, being involved in the supply and erection of the bridge's steel structures, Cowie and Eden Consulting Engineering, concerning the detailed construction design. In particular, Eden will implement an internal QA/QC system on the design working as an independent checking engineer. Cimolai SPA originates from an individual company, Armando Cimolai SPA, established in 1947 by the founder and father of the current owner, Mr. Luigi Cimolai. The company is a major steel manufacturer operating in Italy and abroad, and is highly specialized in the manufacturing of bridges and viaducts, industrial and civil buildings, military infrastructures, normal and special plate girders for the offshore and shipbuilding industries. Cimolai SPA is operating in many parts of the world, such as the United States, Colombia, Venezuela, Brazil, the United Kingdom, France, Germany, Saudi Arabia, Turkey, and many others. Technical, financial, and human resources are a strong asset to this company. Cimolai SPA employs over 1,500 people throughout the world. The total steel production for the year 2006 was 50,500 tons, which was increased to 65,500 tons during 2007. At the end of 2007, Cimolai SPA generated a turnover of €150,885,000, with investments equal to 6% of the turnover amount. Cowie is a Danish private limited company, with the Cowie Foundation as the majority shareholder. Cowie provides consultancy services within the fields of engineering, environmental science, and economics. Cowie's head office is located in Copenhagen. It is supplemented by 11 regional offices throughout Denmark. The Cowie Group maintains an additional 35 branch offices and affiliated offices in Asia, Europe, the Middle East, Africa, and the Americas. Cowie has carried out nearly 50,000 projects in over 175 countries. The company is currently engaged in some 5,300 projects within a wide range of disciplines. Cowie has 4,000 employees, including approximately 2,000 based in Denmark. Cowie employs engineers, biologists, geologists, economists, surveyors, anthropologists, sociologists, and architects. At the end of 2007, Cowie generated a turnover of over €406 million. Eden is a leading Italian firm for engineering design, services, and consulting, with special experience in transportation infrastructure, civil structure, complex engineering problems, diagnostic and elaboration of experimental data, activities of research and development. The proposed group of companies for the execution of the project has already worked together successfully in the past. The Strait of Messina suspended bridge connecting Sicily to the Italian mainland is a fine example of their work. And they are now actually involved in the construction of 2 lots of the Salerno-Reggio Calabria motorway in South Italy. A bridge similar in conceptual characteristics to the 6th crossing suspended arch bridge is the European Celtic Gateway, a cable-stayed arch bridge with a concrete deck. The arch is a fabricated tubular element of varying radius, and the deck is an open box girder suitably stiffened. Another bridge which can be assimilated to the 6th crossing suspended arch bridge, mainly for the realization, is the 221-meter-long cable-stayed orthotropic steel deck arch bridge over the A1 motorway. Designed by architect Calatrava, the bridge has been designed according to a concept scheme named bowstring. In fact, the arch is bowed and compressed, while the deck is tensioned and straight. The bridge is constituted by a single central arch linked to the deck by means of hangers. With a sunburst pattern, the bridge is 221 meters long, and the net span between the abutments is just over 217 meters, while the maximum height of the arch from the road level is approximately 46 meters. The deck is constituted by a central trapezium cross-sectional box girder, with bracket V-shaped clutched every 3.5 meters on both sides to support the 14-millimeter thick orthotropic plate. For the realization of the 6th crossing suspended arch bridge, we'll make use of worldwide resources in terms of materials, manpower, and management. From a technical point of view, the bridge design concept is such that the main structure is formed by 2 splayed steel arches where the arch thrusts are absorbed by dedicated elements of deck functioning as ties. The bridge deck is formed by an orthotropic steel plate suspended by steel hangers, while the abutments shall be founded on drilled concrete piles. The goals we focused on to achieve this are the greater stability and stiffness of the structure, the elimination of horizontal thrusts on the abutment foundations, and to get the best quality of the steel elements for the deck and the arches by manufacturing them in the European Cimolai workshop. During the first construction phase, groups of concrete piles will be drilled and used as provisional piers with spans of 100 meter or 150 meter. The orthotropic deck, pre-assembled in specific areas of the site, will be launched from the rear of the previously constructed abutments onto the provisional piers. In the second phase, the deck will be utilized as a working platform, and provisional steel towers will be erected onto it. A strand jack system will be installed on top of the provisional steel towers to allow the following lift of the complete arch sections. In the third phase, all the pre-assembled elements of the arches will be moved over the bridge deck and finally assembled as arch sections. At the same time, the strand jacks of the provisional steel towers will be connected to the pertinent arch sections. In the fourth phase, the complete arch sections will be lifted in multiple stages by the strands jack system, located on the top of the provisional steel tower to reach the accurate provisional positions for the relevant fitting up. In this particular phase, the hangers will be connected to the arch sections. Finally, the arch sections will be lifted to their final shape and welded. In the fifth phase, the hangers will be fixed to the deck. A complex and important pre-stress sequence will commence in order to reach the design load of each hanger. After the tensioning of the hangers is completed, all temporary equipments, including strand jack system and steel towers, will be removed, and the provisional piers will be demolished.